Hi, good morning. Today we are going to discuss one result. Okay, so before going to the statement of the result, let us recall what is norm of a linear functional. Let f be a bounded linear function. Let f belongs to x star. And what is norm of f? Norm of f is equal to supremum of modulus of f of x such that uh, norm of x equal to 1. Okay. Also, there are some various expansions for norm of f. We have defined like this. Okay. So, supremum of modulus of f of x such that norm of x equal to 1. This is the definition of norm. Now we are going to prove then the result norm of x equal to, let x be here, okay, equal to supremum of norm of f equal to 1 then modulus of f of x such that f belongs to x star, okay, with the norm of f equal to 1. This is what we are going to prove, okay. Before going to the result, let us look at another result. Suppose some x for any some x belongs to x. Suppose mod x is less than or equal to a. For every x belongs to x. Okay. Now we have to find supremum of modulus of x. Okay. Such that x belongs to x. We have to find this. Okay. Suppose there exists a y belongs to x such that mod y equal to a. Mod y equal to a. Then what happens? We have mod x is less than or equal to a for every x. And there exists a y belongs to x such that mod y is equal to a. Therefore, supremum of mod x such that x belongs to x. What about the value? For every x, mod x less than or equal to a. And for this y, value is equal to a. Therefore, supremum of this is equal to a. Okay, we are using this result in our proof. Okay. The result says that norm of x, let x be an element in capital X, norm of x is equal to supremum of modulus of f of x such that f belongs to x star. Okay, satisfies the condition norm of f equal to 1. We have to prove this. Okay, so we know that for any bounded linear functional, modulus of f of x is less than or equal to norm of f into norm of x. That we know. Okay. Therefore, modulus of f of x is less than or equal to norm of x for every f belongs to x star with norm of f equal to 1. Okay, clear? That means for any linear functional f of x, mod f of x is less than or equal to this one. For any f belongs to x star with norm of f equal to 1, we have this one. Okay. Now we have to prove supremum value. The supremum value is equal to this one. Okay. For this, actually we have to prove there exists some function. We have to prove this supremum of this value equal to this one. That means we have to prove there exists some function g, okay, belongs to x star such that norm of g equal to 1 and modulus of g of x is equal to norm of x. That means g belongs to g is a linear function with the norm of g equal to 1. Okay, and mod g of x equal to this one means supremum attained. Okay, hope it is clear. Okay, so here we are going to prove this. Okay, so we know that we have corollary 3.1.4, I think. Okay, for every x naught belongs to x, there exists a f naught belongs to I think x star minus z0, such that f naught of x naught is equal to norm of f naught into norm of x naught. We have this result. Okay, using the same result, we can prove for every x belongs to x, okay, there exists some psi naught belongs to x star such that psi naught of x naught is equal to norm of psi naught into norm of x naught. We can write like this. Okay, now here for every x naught belongs to x. Okay, for every x naught that is for every x belongs to x, there exists a phi naught belongs to x star such that phi naught of x is equal to norm of phi naught to norm of x. Now if you consider psi naught of x divided by norm of phi naught, phi naught, what we get? Norm of x. This is actually over x. Okay. Now you choose psi 1 as psi naught by norm of psi naught. Psi 1 of x is equal to psi naught of x by norm of psi naught. Now what about norm of psi 1? Equal to norm of psi naught by norm of psi naught. And this is equal to norm of psi naught by norm of psi naught. And this is equal to 1. And clearly this one phi naught of x is a linear function and this is a constant, therefore psi 1 x is a linear functional. Also norm of psi 1 is equal to 1. Thus we get psi 1 belongs to x star such that norm of psi 1 is equal to 1. Now psi 1 of, what about mod psi 1 of x? Mod psi 1 of x is equal to modulus of psi naught of x divided by norm of psi naught. All these are norm of psi naught of x, each term is positive. Okay, therefore we get this is equal to norm of psi naught, norm of x divided by norm of psi naught. Cancel each other, we get this is equal to norm of x. Okay. Thus we get there exists a psi 1 belongs to x star such that modulus of psi 1 of x is equal to norm of x and norm of psi 1 is equal to 1 comma psi 1 belongs to x star. Okay. Therefore, supremum of norm of f equal to 1 set of all mod f of x such that f belongs to x star is equal to norm of x, because modulus of f of x is always less than or equal to norm of x for every f belongs to x star with norm of f equal to 1. And here we get norm of phi 1 of x equal to this one. Okay, therefore supremum value of this set is equal to this one. This implies norm of x is equal to supremum of norm of f equal to 1 modulus of f of x. Okay. Okay, so our result is this one. Okay, in the next class we will start our next section, dual operators. Okay, in that section we will prove, we denote dual operator as A star, dual of a linear operator A from x to y. Okay, and there we will prove a norm of A star is equal to norm of A. Okay, for that proof here we are using this result. Okay, so listen carefully. We have norm of x is equal to supremum of norm of f equal to 1 modulus of f of x such that f belongs to x star. Okay.